Welcome. Today we'll solve a calculus problem involving successive differentiation of the tangent function. Let's start by looking at our problem. Let's begin with our initial function. We have y equals tangent of x. To find the second derivative, we first need to find the first derivative. The derivative of tangent x is secant squared x. Now, for the second derivative, we need to differentiate secant squared x. We'll use the chain rule here, since we're differentiating a composite function. Remember that the derivative of secant x is secant x times tangent x. So when we apply this, we get 2 secant x times secant x tangent x. Now, here's where it gets interesting. We can use the fundamental identity that secant squared x equals 1 plus tangent squared x. Substituting this in, we get 2 tangent x times the quantity 1 plus tangent squared x. For our final step, recall that y equals tangent x. Therefore, we can substitute y for tangent x, giving us our final answer. y2 equals 2y times the quantity 1 plus y squared. And there we have it. We've successfully found the second derivative of tangent x and expressed it in terms of y. This is a great example of how we can use trigonometric identities and chain rule to simplify complex derivatives.